Okay, verify an identity. You know, when you see a binomial times a binomial, what is your instinct usually? FOIL. You know, honestly, I'd think the same thing. However, if you look and see what's inside the parentheses, we could probably substitute for these binomials and make them into one term. And we wouldn't have to make 4 terms and see how they combine. So what's the substitution for tan squared plus 1? Secant squared. So just substitute secant squared x. And what will be the substitution for cosine squared minus 1? I mean, which identity is it coming from? Yeah, sine squared plus cosine squared equals 1. You just got to be a little careful with the sign, the plus or the minus, right? Because if it's sine squared x plus cosine squared x equals 1, then cosine squared x minus 1, you would have to subtract the 1 to this side, and then you subtract the sine squared. It's actually negative sine squared. Right? So you don't want to just jump in and say sine squared. Because actually we know sine squared equals 1 minus cosine squared. Cosine squared minus 1 has to be negative sine squared. Okay. Now, looking at the right-hand side, what should I do next? I mean, what does tan squared equal? Tan squared equals sine squared over cosine squared. I've got the sine squared. Where's the cosine squared coming from? The secant squared equals 1 over cosine squared, right? So I can write this as negative sine squared x over cosine squared x. Right? I'm taking that. If it's a secant squared in the numerator, it's a cosine squared in the denominator. And that is negative tan squared. Check. Sure. I mean, look, if you write this as 1 over cosine squared, and this is times negative sine squared over 1, you multiply them, they're all in the same fraction.